problem. A steel rod 40 in diameter is 2.5 meter long. Find the maximum instantaneous stress induced when a pull of 80 kilonewton is applied gradually and second suddenly. Also find maximum instantaneous elongation. Take capital E is equal to 105 GPa. This is the question which we have in front of us. Now let us write the data for this. This is question number 3. Here it is given. A steel rod 40 in diameter is 2.5 meter long. Length is 2.5 meter. 2500 long. Question is find maximum instantaneous stress induced, and we have to also calculate maximum instantaneous deflection. So we have to calculate how much is sigma and deflection, that is delta L. When a pull of 80 kilonewton is applied, the two conditions are given: gradually applied and suddenly applied. So capital P is 80 kilonewton, that is 80 into 10 raised to 3 Newton, and capital E value is 105 GPa. So this is the question which we have. Now since diameter is given, so here the cross section is circular. So this is the question which we have in front of us. Now let us try to get the solution for this. Here we have two conditions, that is gradually applied load and suddenly applied load. So first I will write down for gradually applied load. First we have to find out the stress. So for gradually applied load, since maximum stress is given by sigma is equal to P upon A. So therefore stress is equal to, load is given 80 into 10 raised to 3. Area is pi by 4 into 40 square. So from this we can get the value of stress, that is 63.66 Newton per mm square, the first answer. Next we have to calculate the instantaneous elongation or deflection. So I'll say that since instantaneous elongation is given by delta L is equal to stress into L upon E. So therefore deflection will be equal to, stress we have just calculated 63.66 into the length of the member is given as 2500. Young's modulus is 105 into 10 raised to 3. So from this we can calculate the instantaneous elongation for gradually applied load. The answer is 1.516 mm. We can say the second answer. Now this was up to the gradually applied load. Next we would be using the second condition for suddenly applied load. Here I'll say that since stress is given by sigma is equal to 2p upon A, that is for suddenly applied load. So therefore stress is equal to 2 into load is 80 into 10 raised to 3 upon area is pi by 4 into 40 square. So from this the stress value which I have It is 127.32 Newton per mm square. Third answer. Now, after getting stress for suddenly applied load, we would be calculating instantaneous elongation or deflection. I'll say that since instantaneous elongation is given by delta L is equal to stress into L upon Young's modulus. So therefore, delta L is equal to stress is 127.32 for suddenly applied load, length is 2500, Young's modulus 105 into 10 raised to 3. So the deflection answer which I have 3.03 mm. As we can see from answer number 1, stress for gradually applied load is 63.66. Stress for suddenly applied load is 127.32. So we can say that stress in suddenly applied load will be double the stress in gradually applied load, and therefore deflection will also be double than gradually applied load. So as we can easily see from answer number 1 and answer number 3, stress value in suddenly applied load is more. From answer 2 and answer 4, we can see that deflection in suddenly applied load is more. So whenever there is a question in which the load value and cross section is same, but one is applied gradually and the other is applied suddenly, we can say that in suddenly applied load the stress will be more, and even in suddenly applied load the deflection would be more than gradually applied load. With this we complete the question.